So in this video, we're going to cover Wireshark and how to use it to diagnose a real world problem. So I'm going to give you a little bit of background and explain what was happening, and then we're going to kind of step through how we diagnosed the problem and eventually solved it. So the first thing that was happening is we have a web server and it was just one server, and the customer would go to a website and they would pull up the website, they would start using it, and then at some random point in time the client would stop responding, and so the browser would literally sit and spin waiting for the server to respond to it. And eventually, after about 60 to 70 seconds, the server would finally respond and everything would start working again. And it was totally random. It didn't happen all the time. It didn't happen to everybody. And it was very, very frustrating to try to deal with, because at first we thought we had a problem with the program, with the web server. It was a new server that we had set up. We were afraid we had something misconfigured on the Nginx, or somewhere PHP somewhere had a problem. And so we weren't real sure where to go to look for the problem. We had nothing, absolutely nothing in any of the logs, no hint whatsoever as to what was going on. And so our last ditch effort to try to at least put a finger on whether it was a networking problem or a server problem was to run Wireshark and tcp dump. And so tcp dump is a Linux utility that you can run on a Linux server. And so we ran that on the machine, on the server, and at the same time we ran Wireshark on the client computer. And then what we had to do is we literally had to just sit and click and click and click and click until eventually we got the thing to error out. Once it errored out, we let everything sit. We didn't touch a thing until the server came back. As soon as the server responded, we then killed the dump that we were capturing on the server, and we killed the dump we were capturing on the client. And then we had the long, daunting task of trying to find the problem. Where was the offending packet, the packet that stopped everything from working? Now, when I say long and daunting, it would have been if it weren't for Wireshark. Wireshark is actually a very, very awesome networking tool that you can use to diagnose problems like this. And before we get started in how we actually went about doing it, I'm going to show you a few things in Wireshark about how to use the interface. So up at the top, you're presented with your actual packets that got created or got captured. You've got your information about those packets, the header information down here in the bottom left, and then over here on the right is the actual data. Now, you can set the interface up in a number of different ways. This is not the default configuration, but because most of our traffic comes across encrypted, this right-hand box over here is pretty much useless to us most of the time. So we don't really pay a lot of attention to it. I pay more attention to this section and the packets themselves, so we just made them bigger. But you can set this up any way you want. The other thing is you'll notice that I have things up here for arrival time, and I've got source and destination ports, source and destination IP addresses, and things like that you may not see when you load Wireshark. So you can come down here in this left-hand box here, and you can right-click on things. So let's say that I wanted to add a column for this particular sequence number. All I'm going to do is right-click on it and come up here and tell it to add it as a column, and it'll add a new column up here. Or I want to filter on it, so I want to filter on the selected field, and then you'll notice that I have a filter up here at the top that then orders everything or filters everything so that I'm only looking at the thing or the things that I want to see. Now, having said that, you'll notice that I'm actually filtering up here on a source port and a destination port. And so to explain what happens, the first step is that a computer, the client, your computer at home, wants to talk to a server. The first thing that it's going to do is it's going to select a source port. It's a port that it's going to use to communicate with the server so that when the server responds back, it knows where to send that traffic. And so, and I'm not going to get into a whole lot of in-depth TCP stuff here, but it's just a port, a number that I'm going to receive back. The problem is if I sort or filter on the source port being my client's port, I'm only going to see the traffic that I sent to the server, because at that point the source port was my port, but the destination port, if you look over here, you can see a destination port of 443, which is an SSH SSL connection to an HTTPS server. So I don't want to only look at my side of the communication, because I don't know if I'm the problem. I want to look at both sides of the communication. And so to do that, you have to add an OR clause in here, which is, you can put the word or two pipe symbols, and then you're going to add the other thing, which is the destination port. So I want the source port and the destination port, and I want to see all of that traffic. And you can also, when you right click down here, you can come up and tell it to apply the filter and do the OR here, and it'll automatically add it to the list that you already have. So you can build this with all kinds of different information. So that is just a few basic things about Wireshark. Now, the next thing that I want to talk about is a conversation between a computer and a server, or really two computers, period. But in order for my computer to start a conversation with the server, I have to send what is called a Syn packet. It's a synchronization packet that comes across TCP. It's in part of the TCP protocol. So I'm going to send a Syn packet off to the server. And so if you look here, you can see that this is the source port. It's the port that my computer chose. It's sending it to the HTTPS port on the server. It is a synchronization packet, so it's the Syn packet that my server is sending the server. In a normal conversation, the server is then going to acknowledge, that's the ACK part of this, he's going to acknowledge my Syn packet, and he's going to send me his Syn packet so that I can then acknowledge his packet. So it's called a three-way handshake, and those are the three packets that are always sent in any TCP connection to make sure that that computer is ready to talk to me and that I am ready to talk to it. Once those three packets are exchanged, we then proceed with the conversation, and that we're not really going to get into, because as you'll see in a second, that was not our immediate issue. Now, So just understand that we have to have a Syn, SYNACK, and ACK. And so we're going to come back up here, and now I'm going to actually change this over to my packets. So what we did, again, is we had a sniffer running on the server, we had a sniffer running on the client, and then we used both of those sniffs, both of those captures to analyze what was going on. And so what we're looking at right now is the client side of the conversation. And so the first thing to understand is that without this filter, I would be looking at a ton of data, and with the filter, I have a very, very small subset of information to look at, so it made it very quick and easy to do. The other thing to mention is that if you're on a high volume server and you're trying to do this, it's possible that you're going to have more than one computer out on the internet that chose to use this port. And so if that's the case, you may also have to include the source or the destination IP addresses, some additional information to narrow in on what you're looking for. But the point is that with this filtering, you can get pretty complex in your filter. Now, what you see here is the client side of this conversation, and you'll notice that the client, my computer, sent the server a Syn packet. And if you remember from just a moment ago, the server should respond back to me with a SYNACK packet. But you don't see the SYNACK packet. There isn't one. But what you do see is you see my machine sending another request. This is a retransmission of that first send. It sends it another request, and that was a second after it sent the first one. 3 seconds after that, it keeps doubling this as it goes, but 3 seconds after that, it sent another one, 7, 15, 31, and then remember, 60 seconds later, everything starts to work again. So This is the client side. This is very suspicious because I can see that the client is sending a SYN, but we're not getting a SYN-ACK. So the question is, why are we not getting that SYN-ACK back? And so what we're going to do now is we're going to pull the server side of this conversation into the equation. And so again, I've set a filter up here for that same port. We were lucky enough to only have one computer using it. And so we're going to take a look at what data came across from it. And the very first thing that you see is a Syn packet that was received from the client. This is from the source port to the server's port. So the server did receive that Syn packet, but it didn't respond to it. And the question is, why did it not respond to it? And so you can see here that it also received the retransmissions of that original SYN, and it ended up being that the TCP protocol stack on this particular server was misconfigured, and it had a parameter in it that was causing it to get confused in certain situations when timestamps weren't sent over the way it was expecting. And so knowing this allowed us to go in and drill in on the server itself to try to figure out what the problem was and eventually solve the problem, where you can see without Wireshark and the ability to dump these packets, it would have been very, very difficult to try to figure out, because there were no log entries anywhere on the server to help diagnose what the problem actually was.